this video, we are going to talk about how we can form simplification by using the 3i, 3a, 3d, and the car laws that we studied in Boolean Algebra. Okay? So it's going to be like this. I will give you the expression. Okay, you can pause the video, try it by yourself, and then finally you can unpause the video or play the video to find the answer. Okay, so let's say we have the first question like, how can we simplify this expression? Okay, so if you look at this, you can't actually directly see the idea, but what you have to look for is if you can find any common signals. Okay, so if you can see here, we have b bar and b bar here. Okay, and a bar and a bar here. All right, so those are the common signals. Okay, since we have OR gates here. Okay, what we are doing is we are looking for the common signals in each term. Okay, this is what we call a single term. So in each term, we are looking for the same signal. So here you can either take a bar as a common signal or b bar as a common signal. So I'm going to take b bar as a common signal here. So if I take b bar as a common signal, I have a bar, okay, a bar plus a bar dot t. Okay, so this is why this is what I have, and we know this is according to the distributive law. According to the a bar plus a, which means the inverse law, I can say a bar plus a is equals to 1. So it will be b bar dot 1 plus a bar dot b. Okay, so here you can see this is equals to b bar according to the identity law. And here we have a bar dot b. What I'm going to do is I'm going to write this as b a bar. Okay, I'm going to write this as b a bar because we can change the order, right? According to the commutative law, the order doesn't matter. So we have b bar plus b a bar. Okay, so since this is a signal and this is the inverse of that signal and there is another signal, I can apply the redundancy law. According to the redundancy law, I will get b bar plus a bar. Okay, so the final answer will be a bar plus b bar. If you want to show this in a single gate, if you want to just use one single gate to find the answer, you can use the De Morgan's law to get them together, like reversing the De Morgan's law. So you'll get a dot b whole thing bar. Why? According to De Morgan's law, we have learned that a dot b whole thing bar is equals to a bar plus b bar. Okay, so the things I have used here is, here I have used distributive law. Okay, I have used the distributive law, and then I have used the inverse law. Okay, I have used the inverse law. This is inverse law. Okay, and this one, taking into groups, distributive law. Then b bar dot 1, actually I have used that has converted to b bar by using identity law. Okay, I have used the identity law, and finally I have used the redundancy law here. Okay, I have used the redundancy law. Some people call this absorption law. I'm not exactly sure, but I use the word redundancy law. And then finally, I have used the De Morgan's law. Okay, I have used the De Morgan's law. So this is how you have to simplify a given expression. Now you see why we need algebraic expressions. Yeah, now you see why we need not algebraic expressions. Why we need this is why we need Boolean algebra laws. Okay, so that we can simplify big expressions into simple expressions like this. If you had to do this, there will be requirement of many gates, but here only NAND gate is enough. Okay, now let's do the next question. Let's say the second question is like this. So this is the second question. How do you think we can solve this? Well, we can do this in two methods. Okay, first of all, I will teach you the simplest method. Then we can go to another method. Okay, so since we have a whole thing bar here, okay, you can clearly see a whole thing bar here. What you can do is just break it. Okay, according to the De Morgan's law, just break it and see what happens. So if you break it, what will you get? You will get x bar dot y whole thing bar plus x dot y whole thing bar. Why do you get that? Well, if you see here, according to De Morgan's law, a dot b whole thing bar can be given as a bar plus b bar. Okay, in this case, a is actually equals to x bar dot y whole thing bar and b is equals to x dot y whole thing bar. That's why when we put another bar over these signals, it looks like this. And according to the double inverse law or double complement law, we can cut these two dashes or bars. So you will get x bar dot y plus x dot y. Okay, so here what you can do is you can obviously take y as a common factor, so you'll get x plus x bar according to the distributive law, and finally what will you get? Y into 1, so that is equals to y. Okay, so q is actually equals to y. Okay, so what are the laws that I have used here? The first one is De Morgan's law. Okay, I have used the De Morgan's law. Then I have used what law here? Double complement law. Okay, I have used the double complement or double inverse law. Okay, then I have used the inverse law in this case. Okay, x plus x bar. This is a distributive law, obviously. I have taken things into, like factors. I have taken things common. And here I have used x plus x bar is equals to 1. What is it? Inverse law. Okay, I have used the inverse law. And finally, I have used the identity law. Okay, normally the questions are like this. Okay, so this is the easiest way to do this question. Okay, so let's look at the other way also. Okay, instead of breaking down, I mean, some people won't think about that, right? I mean, they won't go for, De Morgan's law. They don't actually know that it's De Morgan's law. So what they will do is they'll just simplify from inside so that they can find what's outside. Okay, so let's try that also. Here we have, here we have x bar dot y whole thing bar. But if they break that, instead of breaking the whole bar, they are breaking just this signal. Okay, what will you get? Well, there will be whole thing bar. Okay, so this one will be x double bar plus y bar. Okay, and dot. Here you have x bar plus y bar. Okay, what is happening here? I'm breaking only this signal. Okay, I'm breaking only this signal and also this signal. Okay, then what will happen? X double bar is equals to x. Obviously, we know that. So it will be x plus y bar, okay, dot x bar plus y bar. Okay, so now here you can clearly see this has the pattern that we have already learned, the second distributive law. Okay, a plus b dot a plus c. Well, that will be equals to a plus bc. So you can say this is equals to y bar plus, okay, y bar plus x bar. Okay, so this is a here. Okay, and I can say this is b and this is c, or this is b and this is c, doesn't matter. So here we have y bar plus x bar, and according to the inverse law, x bar is equals to 0. Okay, so it will be bar y bar plus 0. So that is equals to y double bar, it is equals to y. Okay, so here also we have used the De Morgan's law, but inside the signal. Okay, we are not considering the entire signal, we are using it inside the signal. Okay, so here we have used De Morgan's law. Okay, here we have used De Morgan's law. Then we have used the well, this is the De Morgan's law here. Then we have used the double complement rule. Okay, or the law, double complement. Then we have used what? We have used the distributive law. Okay, the reverse of the distributive law. Okay, here is the distributive law, and here we have used the inverse law. X bar is equals to 0. And finally, y double bar giving is equals to, well, this is identity, because y bar plus 0 is equals to y bar is identity. Okay, sometimes we will use this law without even recognizing. Then we have double complement law again. Okay, finally we have double complement law again. So there are many methods to approach the same answer. Okay, you can approach the same answer by using different methods, but doesn't mean you're doing it wrong. Okay, so keep that in mind. Always keep that in mind. Now let's do another question. Okay, now let's do another question. Okay, how can we do this question? There are multiple ways of doing this question. Okay, there are multiple ways of doing this question. I'm going to use the simple method that we can do here. Instead of expanding all those things, okay, x bar y is there, so here also we have x bar y, so I'm going to take x bar y as the common factor. So this will be equal to x plus y bar plus x bar y whole thing, okay, 1 plus x plus y bar. Okay, so according to the identity rule, 1 plus anything is equals to 1. So we will get x plus y bar plus x bar y into 1. and we know x bar y dot 1 is equals to 1. Sorry, x bar y dot 1 is equals to x bar y. So here what I'm going to do is I'm just going to change the order here. So it will be x plus y bar plus y x bar. Can you see the redundancy law here? The pattern for redundancy law. There is the inverse of the signal and there is another signal. So I'm going to apply the redundancy law here. So I will get x plus x bar plus y bar. Okay, and the beautiful thing here is that x plus x bar is equals to 1. So 1 plus y bar will also be equals to 1 according to the identity law. Okay, so x plus x bar is equals to 1 is inverse law. 1 plus y bar is equals to y bar is, identity law. Okay, so that is equals to, well, not y bar, it is equals to 1. Really sorry. 1 plus y bar is equals to 1. That's what we learned in identity law. So here, what have I used? Here I have used the distributive law, the reverse of the distributive law. Okay, here I have used the reverse of the distributive law, and then after using that, I have used here this part. Okay, this part I have used identity law. Okay, I have used the identity law. Then here also I have used the identity law, but then I have changed the order. So let's say I have also used commutative law. Okay, I have also used commutative law, and then here we have used the redundancy law. Okay, here we have used the redundancy law. Then we have used the inverse law, x plus x bar. Okay, and finally I have used identity law again. Okay, I have used identity law again. Instead of this, you can also do it in a different way. Okay, because x plus x bar y is equals to x plus y. Yeah, x plus x bar y is equals to x plus y. Yeah, I'll do that also. I'll show you how I'm thinking, my thought process. Okay, this is my thought process. Instead of doing all those things, okay, I'm just thinking x plus x bar y is equals to x plus y according to redundancy law. And then we have y bar according to commutative law. We can change the order. So here we have x plus y bar, etc., etc. It doesn't matter y. Y plus y bar is equals to 1. So 1 plus anything is equals to 1. So the output will be 1. Whatever the input is, x can be anything, y can be anything. The output will be 1. Okay, x can be anything, y can be anything. The output will be 1. That's all. Keep in mind. Okay. So now let's do another question. Okay, let's do another question and finish today's class. So let's say we have x dot x bar dot y bar whole thing bar. How can we do this? Okay, so if you see this, for now, you must have understood the assignment. What do we do? If you see a whole thing bar, we will break that down. So you will get x dot, okay, x double bar plus y double bar. Okay, so that will be equals to x dot x plus y. So that is equals to xx plus xy. Okay, so that is equals to x plus xy, and that is equals to x according to the redundancy law. Okay, that is yeah, exactly. That is equals to x according to redundancy law. Keep that in mind. Always keep that in mind. Okay, so that's it. That's all for this video. I have some more questions, another 4 questions for another video that we practice again and again every day. So these are the basic things that you have to keep in mind. I'm not going to say what are the laws I have used here. Just write them down by yourself. And yeah, you can write questions like this by yourself and practice them, or practice this question again and again. You'll get an idea. That's enough actually. So stay tuned.
Thanks for watching the 10th video in our Logic Gate series. If you found these practice questions on Boolean Algebra Simplification helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master Logic Gates. Follow us on Instagram, and I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.